In this question, we are given a short section of a piece of wire. Actually, piece of copper wire. Okay, so that's kind of a magnified view of this. And we're given that, or we are asked to look at a short section of this copper wire, okay, and to think about the electrons, the conduction electrons in this short section. And this part, this short section is a short cylindrical volume, and okay, and this point is labeled with the letter X. So we are given some details about this copper wire. We are given that the cross section has an area of 3.2 times 10 to the power of minus 7 meter squared. Okay, and we're given that this part here is 0.0047 meter. Okay, this length. And let's see. And we're also given that in this volume, there are 8.5 times 10 to the power of 28 what is called conduction electrons per meter cubed. So meter cube is volume, so that means that per meter cube of volume down here, there are this number of conduction electrons. So the question is, okay, the electrons here, right? All the electrons here. All the electrons here. Okay. Okay, this is what we're given. All the electrons here pass through X. Of course, they pass through X because there is a battery connected to this, and the battery is connected with a negative pole to this end and the positive pole to this end of the copper wire. So all the electrons here we're given pass X in 60 seconds, meaning that they flow in this direction, and all the electrons here would have just flown past this point in 60 seconds. So quite slow if you think about it. All right, in 1 minute, the electron just flows 0.0047 of a meter, which is less than half a millimeter. Right, so that's kind of less than about a half a millimeter. Okay, if you think about this area, you'll find that this if you work out using this area, the diameter of this this wire, or a quick way would be to say that this is about 10 to the minus 6 meter squared, which is the same as the square of 1 mm. Okay, so it's always good to have an idea, have or how this relates to our familiar sizes of things. So this is about, is about maybe a bit less than 1 mm of diameter. It may or may not help with the question. Sometimes it might. Okay, so let's in this case, let's leave it. This is good enough for now. Okay, so yeah, I've still not written down the question yet. Okay, this is what we're given. All the electrons here in this section pass by X, will pass this point X in 60 seconds, and the question is what? Yes. The question is, what is the current? That is the question. Okay. Let's try and do that. Now let's see how we can try and answer this question. If you start by thinking about what a current is charge over time. So it's the amount of charge that flows past a certain point, divided by the time taken. So we have an obvious number for the time, 60 seconds. But what is the charge? We are given that is all the electrons here. Okay, not all the electrons, all the conduction electrons. We have to be careful with that, because not all electrons are conducting. Some are just inside the atoms and they don't move away. So all the conduction electrons. But for the rest of this discussion, I'm just going to call them electrons. Okay, so when I say electrons, I just mean the conduction electrons. Okay, so the electrons here, the Q here would be the charge of these electrons here. And to find the charge of these electrons, we have to think about maybe this information. This information tells us how many electrons there are per unit volume. Okay, so this means that in order to find the total charge of the electrons here, we must first find the total number of electrons and then multiply by the charge of an electron. So let's try that. So what I need to do is I need to find the number of electrons. Okay, the number of electrons will be equal to this quantity here, which we can call the number density times the volume. Now the volume is easy. We know how to find the volume of a cylinder. Just take the length of the cylinder, multiply by its cross-sectional area. So these two multiplied together give us the volume. Number density, we already know. Right? We know how many electrons there are per unit volume. So just multiply that by the volume to get the number of electrons. And then to find the charge would be the number of electrons times the charge of one electron, which is E. And we know what E is. E is 1.6 times 10 to the power minus 19 coulomb. So we have all we need to find Q. So let's write this out. Okay, rather than carrying all these words along, let me make some symbols for them. Let me call this number of electrons N. I'll call this N. And let me call this number density. Let me call it rho. Okay, and let me call this V. Right. So I is equal to, now Q would be number of electrons times E. So NE over T, and N is volume, is density, number density, times the volume. So rho V over N is rho V, so E there for the charge and T for the time. So now we should be ready to put in the numbers. Okay, NE. Okay, rho is where? Oh, that's rho. Okay, that's the number. That's the 8.5 times 10 to the 28. V would be right length times area. So 0.0047 times this 3.2 times 10 to the minus 7. I'm running out of space here. I need to times E as well, which is this number here. So just going to write it down here. 1.6 times 10 to the power minus 19. The whole thing must be divided by T, which is 60 seconds. And now we are ready to use our calculator. And we'll find that the answer is 0.3414, and the unit for current is ampere.